Okay, so this is a video going through the material for section 1-2, day 2, starting off with circles. So I have given you the general form of a circle. There is a number times x squared, the same number times y squared. So both the coefficients of these two terms are the same. Then there's a number times x, another number times y, another number times d. Or, I'm sorry, another number d, which is a constant. So if you see anything in that form, you know that if you went to graph it, it would graph as a circle. Standard form for a circle is after you complete the square and you end up with x minus a number, quantity squared, plus y minus another number, quantity squared, equals the radius squared. And these two numbers, h and k, if you put them in an ordered pair, are going to represent the center of your circle. So if you want to write the equation of a circle, you want to know how to plug in the x value of your center and the y value of your center and the radius. Those are the three pieces of information you need. Looking at 2 points that are the end points of a diameter, you've got a point somewhere up here, 610, and another one, -412, something like that. Those two, if you connected them, would be the diameter of the circle, meaning the circle is going around there. And so if you can take the midpoint, which we learned on the last worksheet, you'll be able to find the center of the circle, the midpoint connecting these 2 points. So the midpoint, we add the x's, divide by 2, add the y coordinates, and divide by 2. So our center is 1, 11. And we could plug that in. We could plug that x value in for the 1, or the, 1 in for the x value of the center, 11 in for the y value of the center, but we still don't know the radius. So we can do this little temporary plug-in. Temporarily plug in one of our points as x and y. So temporarily we'll say 6 minus 1 squared and 10 minus 11 squared. And when we calculate that, that's going to tell us what r squared is. So that's 5 squared, which is 25, plus -1 squared, which is 1. So now we know what r squared is. R squared is 26. That's all of this. So the right-hand side of my equation is 26. So now I know the equation of my circle is x minus 1 squared plus y minus 11 squared equals 26. That's the easiest way to find the equation of that circle. If we have a circle in general form and we want to turn it to standard form so that we can see the center and the radius, that's when we complete the square. The first thing you want to do, the easiest thing to do with this, is to divide everything by 2. Since all the terms are divisible by 2, we could divide everything by 2. And while we're at it, let's gather our x's together and our y terms together. So we'll say x squared instead of 2x squared minus 4x. Leave a little room to complete the square. And then y squared plus 2y, still dividing by 2. And then that 2 that was here, we're going to shove it to the other side where it'll be -2, but we're also going to divide it by 2. So we've divided everything by 2 and we've rearranged it a little bit. To complete the square, we're going to take half of this number, which is the coefficient of x, that's 4, and we're going to square that. So when we do that, we're going to end up with 2 squared, which is 4. We're going to add 4 to the left-hand side of the equation. But very quickly, we're going to add 4 to the right so that we haven't changed this equation's the validity of this equation. If I add 4 to the left and 4 to the right, it still should be equal. We're going to do the same thing with y. We're going to take half of 2 and square it. So we're going to take the y squared plus the 2y, and we're going to add on a 1, half of 2 squared. And we're going to add 1 to the other side. And now that we've done that, this will factor into x minus 2 times x minus 2, or x minus 2 squared. And this will factor into y plus 1 and y plus 1, or y plus 1 squared. And on the other side, we'll just have 4. And so now I know the center of this circle, x minus h, so h is 2, y minus k, this is a minus, this is a plus, so I had to think about it as minus a negative, so my k is negative 1. And the radius of this circle, if this is radius squared, is 2. And then the last thing about circles is you're going to see things like y equals the square root of 36 minus x squared. And you want to know what the graph of that would look like. So if we take a look at this equation and we square both sides, we would end up with y squared equals 36 minus x squared. And if we add x squared to both sides, we can see pretty clearly that this is a circle. Its center is 0, 0, and its radius is 6. However, the original is not the entire circle that we just found, because anytime you square both sides of the equation, you can come up with what we call extraneous solutions. And in terms of a graph, what that would mean is parts of the graph that you aren't going to be able to graph. If you know that the square root, anytime you take a square root, you get a non-negative answer out, that means that y can never take on a negative value for this original. And that knocks out this entire part of the graph because y can never take on a negative value. So this circle that we were talking about that went from negative 6 to 6 with the center at 0, 0, we're only going to be able to graph the top half of it with the original equation we were given. So the bottom half that we didn't graph, that would be expressed as y equals the negative square root of 36 minus x squared, where all the values that come out of that are 0 or below. And that has to do with why if we went backward and took the square root of both sides, we'd have to say plus or minus. We lost the plus or minus part because we squared. And so we only end up with the top half of this circle. So if I wanted the bottom half, I just put a negative out in front of the square root. So that's something you want to remember later on in the semester. You can graph it on your graphing calculator and see it, but you just want to remember that idea. Points of intersection, where two graphs cross. If both of your equations are set equal to y and you want to know where they're going to cross, you want to set them equal to each other, which means you want to set x cubed minus 4x equal to x squared minus 4. And any x values that solve this will be the x values of your intersection points. So to solve this, I'm going to need to subtract my x squared to the left and add my 4 to the left and solve the equation x cubed minus x squared minus 4x plus 4 equals 0 by factoring by grouping. So pull out an x squared, pull out a 4, but pull out as a negative 4. And then pull out your x minus 1 as your common factor. So I'm ending up with x equals 1 as a solution here, and x equals -2 or +2 as a solution for x squared minus 4 equals 0. Then all I've got to do is grab the y values that match those x values by plugging into either of the equations. And I'll choose this one because it has a constant. So when x is 1, y is 1 squared minus 4, which is -3. When x is -2, y is -2 squared, which is 4, minus 4, which is 0. And the same thing happens with 2, because this is an even function. So I have these 3 points of intersection: 1, -3, -2, 0, 2, 0. So to find points of intersection, you set the equations equal. This connects with economics in terms of business calculus by something we call the break-even point, where our cost equals our revenue. So if you have a situation where a business is making a product at a certain cost per unit and selling it at another cost per unit, and you know what the initial investment was, you can figure out whether a company is going to break even. So the first thing we have to do is figure out a way to express the cost for this company. And X is always going to stand for the number of units produced. That's always going to follow through in every problem in our class, that X is going to represent the number of units produced. So this would be read as the cost to produce X units. And from this information, that cost would be 65 cents times the number of units that I produced, plus any other cost that I'm incurring, which would be the $10,000, the initial investment that I needed to get into business. So this is called the variable cost, and this is called the fixed cost. In other words, if I didn't make anything when I went into business, I'd still be $10,000 in the hole. But every time I make a unit, I got to add on another 65 cents of cost. The other kind of function that we need to consider is the revenue function. And revenue also depends on the number of units I'm making. So revenue is money that I'm pulling in when I sell things. And in this case, I set $1.20 for every unit that I sell. So my revenue function is $1.20 times X. That means that revenue is also expressed this way. Little p is going to represent the price all the way through this class. So little p is the price, and if I take the price times the number of units I sell, that's my revenue. So break even occurs when my cost to produce these units equals my revenue from producing these units. That's when I've broken even, and then I'm hopeful that once I get beyond that and sell more units, then I'm going to start making money, which is called profit. So at break even, my profit is 0. So I'm going to take both sides and subtract 0.65x, and I'm going to end up with 10,000 equals 0.55x. I'm going to take my 10,000 and divide it by 0.55, and I end up with this answer, 18,181.81 repeating. Now, one thing that's important in my class is that if you want to answer what the X value, the break-even point is, you don't give me a decimal. Because if X is the number of units, then it shouldn't have a decimal value. So when he sold 18,000 units, he has not yet broken even. So the answer to the first question is no. How many must he sell? We're going to have to round up. He's not going to break even until he's sold 18,182 units. So make sure that you round up, that you give that as an integer answer, not a decimal value. Another concept in business calculus is the concept of equilibrium. Equilibrium is where the supply is equal to the demand. So supply equations show a relationship between the price and the number of units supplied. Remember, price is little p, number of units is x. Demand equations show the relationship between the price and the number of units demanded, which again is x. So if you're given this demand, or this equation, P equals 195 minus 0.52x, and this one, P equals 150 plus 3.2x, the first thing that you want to consider is which is the supply and which is the demand. The way to figure that out is if you are imagining being a supplier, the higher the price, the more you would like to supply. Whereas if you're demanding the product, the higher the price, the less you're going to demand. And so the price and the units demanded have a negative relationship in the demand function, which means this is going to be the demand function. It has a negative slope to it. Slope is the coefficient of x, and so this has a negative slope to it, whereas this has a positive slope to it. This is the supply function. To figure out equilibrium, you want to set your demand equal to your supply. And that would be the place where both you and if you're the supplier, you and the people demanding your product are happy because you have not supplied more than they want to buy, and you have not stopped producing when they still would like to buy your product. So that's the point of equilibrium, that you've produced just enough to satisfy the demand. So we're going to solve this by taking 195 minus 150 and adding 5.2 to 3.2 and then dividing 45 by 8.4. And again, we're getting a decimal value. Now I want you to think about whether you would round up or round down, and there's no really good answer. If you round down, then you're a little bit too low, and if you round up, you're a little bit too high. So I would say, look at this value. If this is less than 5, go ahead and round down and say 5 units would give me equilibrium. But 5 units is not the equilibrium point. A point always has an x and a y value. And the way you would get the y value for this point is you'd take this 5 and you'd plug it into one of these two equations. So now, when I'm grading your test, I need to know what both of those answers are, because we've rounded. If I plug into the first equation, I'm getting $169. But if I plug into the second equation, and I take 150 plus 3.2 times 5, I'm going to get 166. And either of those answers is correct. So when you're doing equilibrium and you're rounding, you're going to end up with 2 possible y values for your point. And either one will be marked right. This is a simplification because what we just talked about was having a linear demand and a linear supply. And we were finding where these two lines met. But demand and supply are not linear. Demand and supply have a curve to them. Because as you move down and your price gets higher and higher, then an increase in price is going to have more of an impact on the people demanding your product than it did when your price was low. So a linear function means that every time you raise your price, the exact same number of units are now not in demand. And that doesn't make sense. That it would be exactly the same rate no matter where you were on your demand curve. So we are going to make a lot of simplifications in this course just to make the algebra doable, and that's just one of them. The other thing you want to know in this section is the shapes of the graphs that you see below here. You need to know how to graph each and every one of them. So, I don't mean grab your graphing calculator, you just need to know what they look like. So y equals x, you want to know that as the line that's sort of 45-degree angle from the origin, and it goes through the origin, and that's what the line y equals x is. Every x value matches the y value. But when you square x, then hopefully you know that you turn it into a curve and you take away its ability to have negative y values come out. So it's sort of bouncing back up again and curving at the same time. If you cube x, then you can get negative values out of it. Negative x's cubed are negative y's, but your graph is curving instead of being a straight line like y equals x. The square root of x has a domain issue that you don't want to put negative values in. And so what happens with the square root of x is you have a starting point when x is 0, and then it increases from then on, but it increases in a curved fashion like this. Absolute value of x is like y equals x if x is positive. So any x value will have the same y value, but when you get to negative values of x, when you put in -5, now we get +5 out. So instead of going down like y equals x does, it bounces back up like x squared. And that's what makes that V shape. And finally, 1 over x takes away the possibility of plugging 0 in. So I'm not doing a really good job of dashing that, but I've got an asymptote here where x cannot be 0. And in fact, also, y cannot be 0. Because if your numerator is 1, that value will never be 0. And inside of these asymptotes, you have two curves that look like this. And that's what the graph of y equals 1 over x looks like. So those are 6 graph shapes that you should know. You should be able to just pull them out of your head and know what they look like without having to actually plug them into your graphing calculator. And that is the end of section 1, 2, day 2.